Right, we are right back, and we are looking at this particular section on exponents and says, okay, I know that this was the first thing you did this term, and I'm trying to make sure that we agree on some things and we iron out our differences, but also we ensure that everybody is on the same page. The first question and the second question require us to rationalize the denominator. How do we rationalize the denominator? To rationalize the denominator, we actually, for instance, in the first case given 5x minus 16 over x. Right, we multiply by what? Strictly speaking, we need to multiply by negative the square root of x over negative the square root of what? Of x. The practice is to make the square root negative. Are we together? And so, if you make the square root negative, but if you multiply, because negative divided by negative is what? Is positive. So even if you multiply by positive over positive square root, it's the same thing. So that now in the denominator here, what you're then getting is square root of x by minus square root of x, you get minus x, right? And in the numerator, you have what? Right, so you can write minus the square root of x into 5x minus 16. We are then having minus the square root of x into 5x minus 16 divided by minus x. So it's equal to the previous step. Negative divided by negative is what? Is positive. So that now in the end, then what we're getting is the square root of x into 5x minus 16. All right. Or if you look at what Tando was also saying, if you have 5x minus 16 divided by the square root of x, okay, there is this practice and it's correct and it's acceptable. If you have, for instance, 5x minus 16 divided by the square root of x, you multiply by the square root of x over the square root of x. If you multiply by the square root of x over square root of x, you get x. And then you have the square root of x into 5x minus 16 like this. And this is also correct. And so, but also, strictly speaking, this is normally what we like doing, multiplying by the negative square root. And obviously you get that, but the negative cancels the negative, giving us a positive here. But also now in the denominator, what we then have is we have here x. Okay, negative divides the negative, giving us a positive, but we have this. Okay, square root of x over x and into the 5x minus 16. But also the same applies here if you multiply also by the square root of x by the square root of x. And the square root of x will sit in front. In the denominator, we have just x there. Okay, now let's look at another question. Number 2. Number 2. Same question, you need to rationalize the denominator. At this time, you have y minus 25 divided by the square root of y plus 5. Okay, do this quickly. Do this quickly. And let me know, please, when you're done. And let me know when you're done. All right. And let me know when you're done. Okay, whoever is done, please alert me and mention that you're done. Okay. Right. Who is done here? No one is finishing. Is it too difficult, is this question, or what? Too easy. I'm trying to get to the basics, guys. So you forgive me. Everybody's sleeping. Anyone home? Tegelelo, how far?
A bit far.
Okay, so you have y minus 25. You divide by, so you can write it as 5 plus the square root of y. Okay, so you can write the denominator like that. But once you've written it like that, you write it as 5 minus the square root of y. 5 minus the square root of y. So that now in the denominator here, you multiply, this is difference of two squares. So you multiply 5 times 5, you get 25. Okay, I lost Pekanelo. Right, so if I happen to lose you, please try to reconnect. If I happen to lose you, try to reconnect. So we have 5 by 5. 5 times 5 is what? Is 25. Then the square root of y times minus the square root of y. What do you get? You get
Y.
minus y, isn't it? Like this. And then in the numerator, you only have the
Recording.
okay. Apologies. I don't know where that feedback is coming from. It's coming from somewhere. So you have 5 minus the square root of y, like so. Right. So just take a look at these and make sure that you sort of understand these, because this is very, very important. And it is extremely, extremely important that you understand these things, because these are the things that are going to make you a medical doctor. These are the things that are going to make you an engineer. These are the things that are going to make you a teacher. I don't know what your dream is in science, but these things will make you to realize your dream. So do not be hesitant. Take these things very, very seriously and listen very, very attentively. So that is what we get here at this point. And okay, so that's okay. So we have at this point, you have this. So you have y minus 25. Tsenulo, how are you, Tsenulo? Right, and then you have 5 minus square root of y. 5 minus square root of y, you divide by 25 minus y. Right, you divide by 25 minus y. But there's 25 minus y, so what you need to do is to make these ones the same. This is y minus 25 and 25 minus y. So you need to actually attempt to make these two things the same. And if you make them the same, what you do to make them the same? So you factor out a negative, right? If you factor out a negative, you can factor out a negative from the numerator, getting 25 minus y into 5 minus the square root of y divided by 25 minus y. So that what you have here, the 25 minus y and 25 minus y, they cancel out. And we have minus into 5 minus the square root of y, like this. So, and once you have written it like that, this can be written also as the square root of y minus 5, because you distribute, you multiply it through by the negative, and then you get this exactly. Any question so far?
Say
Yes.
I do have a question, sir.
What is your question, Tando?
Say, as I can see the numerator,
Yes.
can you like use difference of two squares from the beginning?
Let me see. Yeah, yes, you can. You can, but it's just that the question said do what? Rationalize. Rationalize the what? The denominator. Okay, you can use difference of two squares from the beginning. Yeah, but how do you suggest we do that, Tando? There are many ways to do it, but how would you suggest to do it?
Or like how would it look, the answer?
Yeah, okay, because difference of two squares means what? Difference of two squares means I have a square, I have another square, and we're getting the difference between them, we're subtracting the squares, so that this is a minus b into what? Into a plus b. So this is like called the difference of two squares. One way to do it is to look at the y and write the y as square root of that squared and write 5 squared like this. And then you have this one minus 5, and then this one plus what? Plus 5. So there's another way to do it as well, from the y minus 5. But just that the question said rationalize the what? The denominator. We just did not have to focus on the numerator, but we could factorize the numerator. The y minus 25, we can just factorize it by looking at it as a difference of two squares, because 25 is 5 squared, but y is the square root of y squared, and we could do this, you know? I mean, but the question said rationalize the denominator. Strictly speaking, the student who has done this correctly would have focused on the denominator. Okay.
Okay, sir.
Right.
Thank you.
Yeah, good. There are many other ways to do this. Let us look at this particular question. I'm interested in seeing what is going to be done here. Let us look at this particular question and see what okay. Number 3. Right, here comes number 3. In number 3, we need to rationalize. Rationalize the denominator. Right, if you have 1 divided by the square root of a plus the square root of b. How do we do this one? Please do it quickly. Senulu.
Yes, sir.
Yeah, try this one quickly. Okay, we're just practicing exponents and sets, and then we're gonna do serious things, but I want to see how well you're gonna do these, guys. Okay. I want to see how well you're gonna do this. Right, who is done? Okay, we're gonna have pop-up sessions during the week. Pop-up sessions during the week. I'm gonna let you know about these, but I'll always like notify you the day before so that you prepare yourself that we're gonna have a pop-up session like tomorrow at this time. If that time is not convenient, you suggest even on Saturday, if you are busy at 4, if you know that you are busy at 4 p.m., let me know. Maybe we can have our session at 10 at night. Or we can have our session at 6 p.m. We can start at 6 p.m. But I did not want to start at 10 because some people are going to be sleeping at that time, you know. So that is that is sort of the reason. Who is that now? Rationalize done. Who is not done now here?
Yes, sir. I'm done.
Okay, what did you do, Rationalize?
I multiplied the bottom
Yes.
with what you call with a to the square root of a plus square root of b.
Okay, let me see. Okay, this is the question. So you multiplied by what?
By the denominator, sir.
By the denominator. Let's see what you did.
Yeah.
So, okay. Yeah. All right. Okay, this is what needs to happen. Okay, you need to multiply by this because you need to make it a difference of 2 squares. So it differs by a sign. If it's positive, you put a minus. So that in the numerator, then you have the square root of a minus the square root of b. You divide by, okay, square root of a by square root of a is a. Square, yeah, positive times negative is negative. Square root of b times square root of b is b. And this becomes the answer. So we're done.
Yeah.
Okay, let us practice more. Solve for x. Let's practice more. Okay, this is called drilling. 3 to the power x minus 1 minus 27 equals 0. What is the solution to this one, anyone? What do we do here? Do this quickly and let me know, please, when you're done. Right, please let me know when you're done. Anyone home?
Yes, sir. I'm done.
You're done. What did you do, Rationalize?
I took the 27 and then I factored it to the I turned it into 3 to the power of 3.
Well done. So we have that we have 3 to the power x minus 1. The 27 was brought to the other side.
Right, yes.
3 to the x minus 1. 27 is the same as 3 cubed. When
Yes.
the bases are the same, you equate the exponents. So which means x minus 1 equals 3 because the bases are the same. It means we equate the exponents. If x minus 1 equals 3, then it means x equals what?
4.
X equals 4. And that is the answer. Okay, let's look at this one. Any question on this one, please? Who has a question? Who doesn't understand something here? Because there are many questions we're bringing now on exponents and sets. and inequalities. I'm just bringing those basics here, but we're going to go to the trig things to exhaust term one work. And then the next thing is we're going to do is Euclidean geometry. We're going to spend time on Euclidean geometry as well. Okay, right. This video is recorded, so I'm going to send you the link to this. Okay, now you need to solve for x given a to the power x minus 1 divided by the cube root of 8 equals 0. Can somebody solve for x here quickly? Can somebody solve for x here quickly? Right, what are the values of x here? Or what is the value of x? What is the value of x?
Oh, sir,
Yes,
I got 1/3.
you got 1/3. That is Tando, right? Right, let's check quickly. So look at the solution to this. Right, so you listen to your other friends if you have a question. Let's set ready. We shall have more one-on-one sessions also during the week in the evenings. So this a to the power x, but you move this one to the other side. If you move it to the other side, it becomes 1 over the cube root of 8. 1 over, we just moved this minus 1 over the cube root of 8. Right, so if you have 8 to the power x, 1 over the cube root of 8. What is the cube root of 8? Okay. Now, this is the same as the cube root of 8 is 2, if you like. You can write 2. But you can also write 8 to the power 1 over 3, because if there is no power here, you can put power 1 there. So that now the cube root becomes this. And then this means 8 to the power x is 8 to the power minus 1/3. The bases are the same. If the bases are the same, what do you do with the exponents? You equate the exponents, which means x is minus 1/3. Any question? Where's the question here? Where's the different suggestion? Where's the different suggestion here? Where's the different suggestion? Or where's the question? Or who thinks the answer must be 1 million? Somebody thinks that the answer must be 1 billion. Who thinks the answer must be 1 billion and why? No one? Everybody's thinking the same, in the same way. All right, let's look at the next one. Twenty-seven. 27 into 4 to the power x is equal to 64 times 3 to the power x. Solve for x here, guys. And let me know when you're done, please. Solve for x here and let me know when you're done, please. Quickly. We don't have lots of time. We have very, very limited time. I want us to do a lot of things. Sundays at 4 p.m. we have lessons. But if you are busy at 4 p.m., you alert me so that I can schedule time for you. Because you are busy at 4, then with you, we can start at 6 when we finish this one. But I'm starting at 4 so that you can do other things. Because I'm starting at 4 so that if you need to go to church, you can go to church and then come back from church and at 4 join us, something like that. You know? That's the reason why I chose 4 p.m. Some of you might need to do extramurals. You might need to go play soccer in something of that sort. So those are the reasons. Who is done here? Begelelo, how far?
Almost done, sir.
All right, thank you. So we're going to look at the solution. So here we're saying solve for x. That is what we're saying. Solve for x. Tando, how far? Tando, how far?
I'm almost there.
All right, thanks. Please finish up. Right. Okay, who is done here, guys? We must finish. We need to finish.
So x is 3.
Okay. General thinks x is 3. What do you think, Pegelelo? What do you think x is?
I'm still stuck, sir.
All right, that's fine. Right, so what we do here, we need to solve for x, and to solve for x, what we do is we associate these terms and sort of group like terms, etc. Right, so the terms with x, we can put them on one side, those without x, we can put them on the other. So we have 27, 4 to the 4x, which is equal to 64, 3 to the power x. We divide the right by 64 and this one by 64. All right, so this one cancels out. Divide by 64, this one cancels out. And when it cancels out, we are left with what? We're left with 27, 4 to the power x over 64. 27, 4 to the power x divided by 64, which is equal to 3 to the power x. And then now, here, we need to divide by 4 to the power x. So you're gonna multiply by 1 over 4 to the power x. 27 times 4 to the power x, 64. And then you have 3 to the power x. 3 to the power x, you multiply by 1 over 4 to the power x. So this practice, it allows us to divide by 4 to the power x. And if you do that, but whatever you do on the left must be done on the right. So that in the end, what you're doing is 27 over 64, which equals 3 to the power x over 4 to the power x, which is 27, which is 3 to the power x over 4 to the power x. 27 is the same as 3 to the power 3. 64 is the same as 4 cubed. This is 3 over 4. If the powers are the same here, you take one common power, like this. 3 over 4 to the power x. 3 over 4. Yes, sir. Mr. Nkosi, how are you, sir? Yeah, can I call you back maybe after 6, maybe at 6:30 because I'm in class now. Is that possible at 6:30? Yes. Okay, yeah, you see, it's reconnecting the network here on WhatsApp. It's reconnecting here on WhatsApp. Okay, guys, there is the solution. Where's the question about this one? Okay, let's go back. This is what we started with. 27 into 4 to the power x equals 64 into 3 to the power x. You solve for x. Here's the solution. It's 27 into 4. Now, here we just had to divide by 64. Why? Because we wanted to move the 4 to the power x to one side with the 3 to the power x, and the 64 had to divide 27. And so now we first divided by 64, but whatever we do on the right must be done on the left. Divide by 64 and you got this. And then after this, we divided by 64. And now the 4 to the x had to be removed. And so that we have, right. Yes, Mr. Nkosi, the network is reconnecting, you know. Okay. Right, then you have 4 to the power x, and then you have to divide by 4 to the power x both sides, both left and right. And if you divide by 4 to the power x both left and right, you therefore have 3 to the power x divided by, right. So you therefore had, right, okay. So you have the 4 to the power x in the denominator, and therefore you have 3 to the power x over 4 to the power x, and then you have 27 over 64. 27 over 64, 3 to the power x, 4 to the power x. And now, here, 27 is the same as 3 cubed. 64 is the same as 4 cubed. Okay? And therefore, now, this one is when they have the same power, you can write like this using the laws of exponents. You can write 3 over 4 and you raise it to the cube. And then you have 3 over 4, you raise it to the power x. And when the bases are the same, you equate so that x equals 3. And the answer is 3. So we continue. Okay, we continue. If you have a question, please let me. Next question. Next question. Let's look at this one. You solve this one, D. Let me just put a point. So here you need to solve for x. Let me give you 2 minutes quickly, please. Solve for x, guys, and let me know when you're done. Solve for x and let me know when you're done. What do we do, Pehalelo? What do we do first here?
Square both sides.
We square both sides. Well done. Okay, I knew that Pehalelo was going to get that one right. I felt it. I felt that Pehalelo was going to just be able to say, okay, we just square both sides. Right, because we have this, we square both sides of the equation, and we square on the left and we square on the right as well. Right, like so. And then if we square like that, which means 2x minus 5, and then you square 2, 2 squared is 4. The next 2 times minus x times 2. 2 times minus x is minus 2x times 2, which is minus 4x. Right, you square the minus x, you get x squared like this. So what we're then getting is twice x minus 5 equals, then you have 4 minus 4x. 4 minus 4x plus x squared. Right. Right, so which means we have x squared, then we have minus 4x minus 2x, which is minus 6x, minus 4x minus 2x, which is minus 6x, then we have 4 plus 5, which is a 9. What are the factors of this? To get
3 and 3.
3 and 3, well done. Okay, to get the factors there, I know they're very easy, but I want to train you to just learn this method and make sure you understand this method. You multiply x squared with 9. If you multiply x squared with 9, you get 9x squared. What are the factors of 9x squared that give minus 6 when added? They are minus 3x minus 3x. So that in the end here, you have x squared, you have minus 3x plus 9 equals 0. Okay, I just want you to just grasp this method. And then now you factor out x from the first 2, which is x minus 3, which is x minus 3. Okay, x minus 3, which is x minus 3. X minus 3 equals 0, which is x minus 3 x minus 3. Okay, well, if you solve here, this means x is 3, or x is what? X is 3. But you need to check if x equals 3 satisfies the original equation. So, right, you need to check if you're given, for example, okay. If you're given twice x minus 5. And 2 minus x. Okay, if you put 3, right, the right-hand side, the left-hand side, which is 2 into 3 minus 5. What is 2 times 3? 2 times 3 is 6. 6 minus 5 is a 1. Square root is that. Square root of 1 is 1. The right-hand side is 2 minus x, which is 2 minus 3. We're substituting into the original. 2 minus 3 is minus 1. Right, looking at this now, what is then your conclusion? Because the left-hand side is 1 and the right-hand side is a minus 1. Then what is the answer to this question? So there is no solution here. Because then the conclusion, therefore, out of this is therefore that the left-hand side is not equal to the right-hand side. So that x is not 3. Because it was only x equals 3 here, it means there is no solution. No solution, because we expected x is only 3. But the 3 is not working because the left and the right are not equal. The left hand side is 1, the right hand side is minus 1. So the conclusion is therefore is that there's no solution. Let's look at the next question. Show that the square root of 3 to the that minus 3 to the power x divided by 3 to that plus 3. Okay, show that this square root is equal to 3. Is equal to 3. All right. Okay, do this one very quickly, please. Show that this square root is equal to 3. And let me know when you're done. Very fast. Very fast. Very, very fast. Parallel, how far?
A bit far, but
Okay, you're getting there. You're getting there. Okay, please move on quickly. Move on quickly. Okay, who is done? No one is finishing here. Why? Sanulo, how far?
Close, sir.
Okay. All right, let's finish up, guys.
Yeah, sir, I'm done.
Right, what answer did you get, Sanulo?
3, sir.
Thank you, thank you, thank you. I wanted to check. All right, so let's look at the solution to this. Thank you so much there. You can see the others are still, how far, Tando? Three to the power x plus 1, 3 to the power x, divided by 3 to the power x minus 1 plus 3. Okay. This is 3 to the power x times 3 to the power 1 minus 3 to the power x divided by 3 to the power x minus 1 plus 3. Right, and we close here like this. So that you have 3 to the power x times 3 minus 3 to the power x divided by, in the denominator, there's 3 to the power x minus 1, but you can write it as 3 to the power x times 3 to the power minus 1, but there's a 3 here. Okay. Right. Senator obviously was able to get a 3. Okay, so you pull out the common factor from the numerator because there's 3 to the power x here in the first two, in the two terms, and you get exactly this one. And there is 3 to the power x times 3 to the minus 1 plus 3. Right, so now you cancel this out. So you have 3 minus 1. What is 3 minus 1? It is 2. And then the 2 now can be multiplied by the 3 to the power minus 1. The denominator becomes 3 to the power plus 1. If it moves up to the same level as the 2 plus 3. What is 2 times 3? It is 6 plus 3. What is 6 plus 3? 6 plus 3 is 9. The square root of 9 is what? It's 3. So we've shown... Yes, please, Pehalelo.
I first squared like in the beginning, so I
Okay.
got 9.
Oh, you got 9. Okay, that's excellent. Because if you squared everything, you obviously could get 9. And therefore, you'd have to remember to say, after you squared, what did you remove? You removed the square root. So you'd get a 9. And therefore, put back the square root here. Because obviously, we don't normally put back the square root. We don't put back the square root in the case of equations when this is equal to something. When this is equal to this, we don't put back the square roots. But if you square a single expression like this, you need to put back the square root at the end when you get the answer. So you got a 9. Therefore, take the square root of 9, which is what? Which is a 3. Okay. So that is what we get. Okay, let us practice more. Okay, can we recap on the laws of exponents? Because some people forget the laws of exponents. What are the laws of exponents? What does law number 1 say? A to the power m times a to the power n is equal to what? Is equal to m plus n. If you have a to the power m divided by a to the power n, this is equal to what?
A M minus N.
Please come again, Pehalelo.
A M minus N.
Well
A to the
done.
power N minus N.
Yes, thank you. Okay, what about if we have a, b all to the power n? What is this equal to? What is this equal to?
A N times B N.
Well done. A n times a to the power n times b to the power n. Number 4. If you have a over b to the nth power, what is this equal to?
A to the power N over B to the power N.
Well done. A to the power n over b to the power n. Number 5. If you then have the law that says a to the power m all to the power n, what is this equal to?
A M times N.
It becomes a m n.
No.
Right. So obviously it's common practice that this is true where A is bigger than 0, B is bigger than 0, and Mn is an element of what? Of the set of integers. I did these laws, the 5 laws, but there's law number 6. There is law number 6. If you have A to the power 0, what is the answer here?
1.
It is 1, provided that A is not 0. There are certain things we call the rational exponents. Rational exponents. Number 1. A to the power 1 A to the power 1 over n equals what? Okay, write this one with the radical sign. A to the power minus 1 over n is equal to what? A to the power m over n is equal to what? Okay, let's look at the top one. If you have A to the power this, it is the same as the nth root of A. It is the same as the nth root of A. Because if there's no power here, it means that the A is to the power 1 like this. And then you just write A to the power 1 over n, which is this. Okay. Now, if it is A to the power minus 1 over n, it can be written as A to the minus 1 times this, which is the nth root of 1 over n, or 1 over A. Okay, you can write like this. So if A is to the power minus 1 over n, you can write it like this. So this is A to the power m Okay, so this base, the denominator here, I can write it like, yeah, the denominator n in the exponent, you can write it like this. So that now you have the nth root of A to the power m. The nth root of A to the power m. Okay, let's look at the simplification of the simplification of sets. Simplification of sets. If you have the nth root of A the nth root of A and then nth root of B. What is this equal to? Number 2, if you have the nth root of A over B, this is equal to what? 3. If you have okay, let me write 2 properly. if you have this is equal to what? Three. Okay, let's put the 3 here. The mth root. The nth root. What is the answer here? Number 1. How can you, what is that equal to there in number 1? Anyone? Anyone?
So isn't it AB to the power
Yes,
1
AB.
over M?
Yes, AB. Right, that's correct. But you can still write it like, because it's the nth root of AB. Right, this one, you can also write it as AB to the power 1 over N. Same thing. What about this one here? So if you have 1 nth root, you can break it into 2. If you have 1 nth root, you can break it into 2 pieces. But also this one, you can break it into 2 pieces. But now here, nth root of the nth root. Yeah, can write it like that. So those are the things you need to take note of. Let us simplify something here. Simplify using the laws. Okay, this video is recorded, so if you did not see something well, you'll have a chance to replay and watch. Right, so let us look at this one. Simplify these. If you have 3 times a to the minus 2 b to the 15th power. Okay, so we have this. Okay. Now simplify this one quickly, please, and let me know when you're done. Simplify this one quickly using the laws of exponents. How far? Anyone? Hello, how far? Tando. I hope you're not sleeping, Tando.
No, I'm awake, sir.
All right, thank you, Tando. Right, please let us know what you think the answer is to this question. Right, so who is done here? It's like no one is finishing. Why? Everybody is solving. Everybody is solving, but there must be a time when people are going to be done. Finished. At some point, you need to finish, you see. At some point, you need to finish. Who is done?
So I'm done, but I don't know if I'm right. I'm not sure.
What answer did you get, Zenulo?
It's 3a to the power of negative 20, b to the power of 225 over 2, c to the power of 25 over 2.
All right, that's fine. Let's just practice together. So it is this here, b to the power 15, c to the minus 5, all divided by. Okay, you have this one here, which is to the power. So it is a to the power minus 4. Separate this one, and it becomes minus 5 over 2. And then it becomes b to the power 3. But the b to the power 3, you raise it to minus 5 over 2. And you also have c to the minus 5 out of 2. You write it like so. And upon further examination, you are able to see that this is exactly the same as the following. Right, so the 3 is okay, but you have right, let's just multiply the bottom things a little bit. So if you have the bottom things, so you have 3a to the minus 2, b to the 50th power, c to the minus 5. So which is exactly minus 5 divided by, so this is a to the power. So here, what is 4 times 5? Is 20 divided by 2 is a 10. And then this one here is b to the power minus, it's b to the power minus 15 out of 2. And then this is c to the power minus 5 out of 2. Right, so what we've got right now is that it is actually 3a to the minus 2 times b to the 15 times c to the minus 5. Okay, so times b to the 15 times c to the minus 5. You divide everything by, right? So the bottom is a to the power 10, which is b to the power minus 15 out of 2. Right, so this is exactly minus 15 out of 2 times c to the power minus 5 out of 2. And then this then is 3. You have the base A. So the base A now you minus 10 because this A was positive, but if it goes to the top, it's going to be negative. Then we have base B to the power 15. Then this one goes up and then it becomes 15 out of 2. And then you have C, which is minus 5 plus 5 out of 2. So this is 3A minus 2 minus 10, which is minus 12. B to the power. Right, so this one, 15 plus 15 out of 2 is 2 by 15. 2 by 15, just multiply this 2 by this 15 and get a 30. A 30 plus 15 is what? Is a 45. So you have a 45 out of 2. Then you have C. This one here is the same as you multiply 2 by minus 5. What is 2 times minus 5? It's minus 10. Minus 10 plus 5 is actually minus 5 out of 2, like this. Right, so, and that is what we are getting exactly. So, now looking at these, obviously this is what we've got. And this is, or actually it's the answer to the question. And therefore, we basically are done with this. And now very little can be done, but it is recommended that answers must be written with positive exponents. So, which means you can write these as b to the power 45 out of 2. And then the negative exponents, you bring them to the denominator so that they are positive. Right. Now, can anything be done with this? Well, pretty much very little, but this is the answer to the question. Any question? Okay, now there are more things that we're gonna do. And now you need to get ready because we're gonna be solving so many things. So many things. So now let's just continue and attempt to solve all these problems here and make the most of our time. So we most certainly are doing very well. So yeah, just stay tuned because we are continuing and we are solving more and more problems, So get ready, get ready, get ready, get ready, get ready. Right. Okay, I'm uploading more problems now for us to practice because I'm just trying to bring up the basics that some of you guys sort of leave out and sort of forget about. I want to see how well you can be able to remember these basics and put them into use. Right, so stay tuned for more. All right, stay tuned for more things, more learning to happen. So, okay, let us look at another question. Right, another question would be, simplify this one. Right, if we have 9, a to the power 6, b to the power 4, raised to the power 1/2. Try this one. Try that one. Let me know, please, when you're done. Anyone? Okay, you're done. Who is done and who is not done?
Oh, I am answer.
Okay, what did you get?
Three.
Tando? Yeah.
I got
Yes.
3a cubed
Yes.
b squared.
Okay. Right. So obviously this is going to be 9 to 1/2 a to the 6th power 1/2 b 1/2. So the square root of 9 is 3. 2 divided 6 gives us 3. Half of 4 is 2. So it's b squared. And that is the answer. The next question says expand. Let us expand. Expand the square root of x minus 2 into the square root of x plus 2. Okay, if you expand this, what do we get? The solution, please. If you expand this, what do you get? What do you get when you simplify, when you expand that?
You get x minus 4.
Get x minus 4. Why? How do you get that turned? I mean, you're right, but how?
X into x.
What you do?
So I multiplied x, square root of x times x square root of x. Then I got x.
Square root of x times the square root of x gives us x, yeah?
And then square root of x times 2
Square root of x
equals it is 2 square root of x
next.
minus 2 to the square root of x minus 4.
And
then these
uh-huh.
are like terms.
These are
So
like
they
terms.
can.
Is that the answer now, my x minus 4? Okay, that's the correct answer. Thanks, Tando. Okay, now let's solve this one for x. Solve for x if we have 2 to the power 2/3. Okay, let's solve for x here. Let's solve for x here. Right, please let us know when you're done. Let us know, please, if the question is not visible for any reason. Right, who is done?
I'm done, sir, but I'm not sure.
What did you get, Tando?
X is equal 1/8.
Okay, x equals 1/8. Okay, that's fine. Let's hold it there. Pekadelo, did you solve the question? What did you get? Is the answer?
I'm not done.
Please come again.
I'm not done. I'm
Okay, that's
still.
fine. You're still working on it.
I'm
Okay,
done, sir. He's right, sir.
he's right, eh?
Yeah, he's right.
All right, all right. Okay, Tsenolo agrees with you there, Tando. Tsenolo agrees that you are right. So, I would imagine that you're right. Let's just look at it together. Right. To solve this question, you can look at x to 1/3 and you square these. 3x equals 0. You let x to 1/3 equals k. So that 2k squared plus 3k minus 2 and equals 0. So this is what we call the k method. Right, this becomes what we call the k method. And upon further examination, so we have 2k squared plus k squared plus 3k minus 2, which means you have 2k squared. You multiply by minus 2 and is minus 4k squared. So you multiply the 2k with minus 2, and then after you got minus 4k squared, look for the factors of minus 4k squared that give 3k. So they are actually 4k and minus k, which means you have 2k squared plus 4k minus k minus 2 equals 0. Pull out 2k here, which means that you have k plus 2, and then you have k plus 2 equals 0, which means that we have k plus 2 into 2k minus 1 equals 0. And this is k equals minus 2, or k equals 1/2. Right, so we have got that k is minus 2, or k is 1/2, but you have that k is x to the power 1/3. So that now, because we said here that x to the power 1/3 is k, so which means that here, wherever the k, we can put x to the power 1/3 equals minus 2, or in the place of k, you put x to the power 1/3 equals 1/2. Okay, this one now, because it's x to the power 1/3, you cube the left and what you cube the right as well to remove the 3. So 3 cancels 3. And x is what is minus 2 cubed? Is minus 8. And then now this one is x to the power 1/3. You cube this and you cube that, which means x is 1/8. So x is minus 1/8 minus 8, or x equals 1/8. Right, so that's what we get is the answer to this particular question. So who has a question here? Okay, now, is that what you got? What did you get, Nintendo?
X is 1/8. Because when I replace -8 to the equation,
Yes.
I don't get a solution. I don't get
0.
0.
Okay, that's fine. Let's just check that. Okay, just need to just cross-check these 2x to the power 2/3 plus 3 x to the power 1/3 minus 2 equals 0. I'm just checking. Okay, there are two solutions to this problem. Namely, they are -8 or 1/8. So the two solutions to this are -8, 1/8. -8 or 1/8. Yeah, okay. Now the question of whether if you put both of these, they must give 0. Let's try, yeah, okay. Because we did not square the original one, both sides, etc. So it must actually work. So you can do a check. Right, so now the check will be as follows. So you'd have, we're checking x equal to minus 8 because Tando was saying it is a little bit, it does not give 0. But let's check this one. So we have x equals 2/3. X to the power 2/3 plus 3x to 1/3 minus 2. And we are putting in the place of x -8 to 2/3 plus 3 to the power -8 to 1/3 minus 2. So which means that at this point, the 8 can be written as -2 cubed. And then it is 2/3 plus 3 into the -8 can read as -2 cubed, but you multiply by 1/3. So what we're then getting here is this one cancels and this one cancels, which means it is 2 to the power. So here you have -2 squared plus 3 into -2 because the powers cancel out here. So what we're then getting is the following. So you're getting 2 to the -2 squared. 2 to the -2 squared plus 3 into -2 plus 3 into -2. Okay, this one is a 4, which is 8 minus 6 minus 2, which is 8 minus 8. What is 8 minus 8, Tando? It's a big zero. Meaning we get 0 if you put -8. Okay, now I want us to discuss something called the nature of roots. The nature of roots, because the nature of roots form part of the syllabus, and we need to discuss the nature of roots, but we need to discuss the nature of roots very, very carefully. Let's look at the nature of roots. Nature of roots. Right, so if you have delta like this, delta is equal to what? Is b squared minus 4ac. Right, so delta itself has two outputs. Either the delta is negative or the delta is greater or equal to 0. If it is negative, what does it mean? Imaginary or non-real roots. Delta is equal to 0, you have the roots are real roots. Now, if the delta is greater or equal to 0, you have two cases. So you have delta greater than 0. And the delta can be equal to 0. If the delta is equal to 0, then we say we have equal roots. If the delta is greater than 0, you have the unequal roots. Then now, the delta is greater than 0. If the delta is greater than 0, right, so the delta can be squared. Or the delta can be not squared. Okay, because sometimes the delta is squared, sometimes it is not squared. Okay, if the delta is squared, then you have rational roots. Okay, if it's not squared, then you have irrational roots. Okay, this is just a mind map on the nature of roots. Let's look at a small example. Right, this example says, show that the roots, show that the root of x squared minus 2x minus 7 equals 0 are rational. Solution? Show that the roots of that equation are rational. What do we do? Okay, do it quickly and Okay. Who is done? Who is done? Who is done? Hello, how far?
Almost there.
Okay, Tando, how far?
I say we use the nature of roots.
Yes, we use the nature of roots formula to show that the roots are rational. To show that the roots are irrational. You show that the roots are irrational.
For them said to be irrational, delta has to be greater than 0.
Yes, for them to be rational, delta must be greater than 0, and what else? Is it only?
Delta should be also equal to a non-perfect square.
Yes, it should not be a perfect square. So, you're right there, Tando. So we're looking at x squared minus 2x minus that. So what is a here? A is 1, b is what?
-2.
And then c is what?
-7.
-7. Well done. Thanks, Pekhalelo. So that when you look at the delta is b squared minus 4ac, so we put in the -2, and then we square it to -4. The a is 1, the c is -7, and the answer is what? If you do this, is 32. 32 is not, okay, 32 is greater than 0.
Mhm.
Okay, so what we can realize is that 32 is greater than 0, but so delta is equal to 32, which is greater than 0, and is not a perfect square, which means that, which implies that roots, which implies irrational roots, which implies irrational roots, irrational roots. Which implies irrational roots. Any question? Irrational roots. Where's the question? No question. So let's look at the next problem. Okay, this is recorded, so I'll have a chance to see this. For which value or values of k will the roots of 6x squared plus 6, which is equal to 4kx, be real and equal. Right, let's look at the solution. Right, let's look at the solution. So in other words, at this point, for which values of k will the roots of 6x squared plus 6 equals 4kx be real and unequal? Try that one quickly. Okay. 2 minutes. Done. Who is done? Or you can't see the question. How far, Tsanulu?
Coming, sir, coming.
All right. Finished. Please, guys, finish quickly. We don't have the whole night here.
So I got k is equals to 3. Wrong. I don't know.
How far? How far? How far? Please, come on.
Sir,
Yes, Senulu.
I got K is equals to 3, sir.
Okay, that's fine. Let me get another answer from Tando. Tando, what did you get?
For real and equal roots, delta has to be equal to 0.
Yes. Right, good. So we actually look at the question, which is 6x squared plus 6 equals 4kx. And this is 6x squared minus 4kx plus 6 equal to 0. And this is called the standard form. This is called the standard form. Right, so if you have 6x squared minus 4kx, six x squared minus 4kx plus 6 equals 0, which means A is 6, B is minus 4k, C is 6, which means this is B squared minus 4AC. And then now just substitute everything. The B is minus 4k. You square this minus 4A is 6, C is 6. And you square this, which is exactly 16k squared minus 144. And for real and equal roots, for real and equal roots, it means delta must be equal to what? 0. If delta is equal to 0, that means 6k squared minus 144 is equal to 0, which means 16k squared minus 144 equals 0. And upon further examination, you can divide through by 16 here. If you factor out 16, you have 16 minus 9, which is 0, which is 16 into. Right, so this one is like k squared minus 3 squared. A squared minus b squared. This is a minus b into a plus b. And this is called the difference. Difference of what? Of two squares. So if this is the difference of two squares, what we're then getting here? 16 into k minus 3 into k plus 3 equals 0. Those are the factors. And then, which means k is 3 or k is minus 3. Right, so we're to get the values of k, so we've got them. Here they are. K is 3 or minus 3. Okay, because obviously, you know, it was easier because they'd already said here, there must be real and equal. So, and real and equal just simply means that the discriminant is equal to what? It's equal to 0, that's all. Right, so let's look at the next question. Let's look at the next question. Let's look at the next question. Show that the roots of x plus h, x plus k equals 4d squared are real for all real values of h, k, and d. Solution. Okay, do this one quickly. Show that the roots of that equation are real for all real values of. There you need to first multiply out. You need to first multiply out and write this equation in standard form. That's what you need to do there. How far? How far? How far, guys? Are you sleeping? Maybe people are sleeping. Tando, are you sleeping?
No, sir.
All right, please finish off. How far, Tsenulo?
Yes, I'm coming, sir.
All right, fine, thanks.
Shut up.
Pegalelo, how far?
Almost done.
All right, thank you, guys. You need to multiply out, guys, there and write that equation in standard form and then solve. But want to show that the roots are real for all real values of h, k, and d. If the roots are real, what does it mean? It means, therefore, that delta itself must be greater than 0 or equal to 0. Greater or equal to 0. Right. Finish off, please. Finish off, finish off, finish off, or finish up. Finish up. You can't be sleeping on this question. It's just one small little question. We still have like lots of questions to do. Tomorrow at 4 p.m., we are continuing with more and more problems. Saturday, 4 p.m., Sunday, 4 p.m., working hard. And we want to go on and on. So please, you need to push harder and faster. To push harder and faster. Yes, Mr. Nkosi. How are you, sir? All right, yeah, I'll call you back just now, but I'm still in class. Is it possible that maybe I get back to you like at 7:30, please? 7:30, sir. Right, please show that the roots are real for all real values of H, K, and D. And to show that those roots are real, we need to show that delta is greater or equal to 0. That is all. Who is done? Like no one is finishing here. Tando, how far? Are you sleeping, Tando?
I am not.
All right, Tando is not sleeping. Tenulu, are you already sleeping?
No, sir.
All right, please finish up. Perelelo, it's like you're already sleeping. Are you sleeping?
No.
Because I'm not hearing you. It's like you're not telling me that you're done. This you must finish in 2 steps, 3 steps. Two steps, 3 steps.
Please show us those 2-3 steps.
I trust you guys. I trust you guys. That is why I'm first giving to you, so that you can prove yourself. You can prove yourselves to to us that you know what? To the world. Right. So you have x plus h. Let's just do it quickly because it's very easy. X plus k. I don't know why people are not finishing. And then 4d squared. Okay. Now we want to show that the roots are real for all real values of k, and multiply x by x, you get what? X squared. X times x by x. X by k, you get kx. Right. You get kx. H by x, you get hx. H by k, you get hk, which is 4d squared. Right. So we therefore have x squared plus kx plus hx plus hk equals 4d squared, which means with x squared plus, these ones are like terms. So it is k plus hx plus hk minus 4d squared equals naught. Right, so upon further examination, if this is exactly hk, okay, so a is equal to what here, anyone?
1.
B is equal to what? B is equal to what?
K plus H.
K plus H. C is equal to what?
HK minus 4D squared.
Thank you so much. Which means we just now proceed to find delta, which is b squared minus 4ac. B is the K plus H. Square this minus 4a is 1. C is hk minus 4d squared. So now this means delta is equal to, so you square everything. So here if you square k plus h squared, which is k squared, k by h by 2, 2kh, and then you square h. Multiply minus 4 into this, which is minus 4 hk plus, okay, now that's negative by negative, which is a plus, then 4 by 4, 16 d squared. Right, so you can write here plus 16 d squared. Okay, now that's what you get. What is the answer? So now what we then have is that delta is k squared. Okay, now you have 2kh minus 4hk. These are like terms and they give minus 2 kh. Right, and then you have here plus h squared. Right, and then what you then have is plus 16d squared. Right, so if you have these, now you can factorize these. The factors of these are k minus h into k minus h, or k minus h all squared plus 16d squared. So this is k minus h squared plus 4d squared. Right, for real roots, the discriminant must be greater or equal to what? Greater or equal to 0. we know that now at this point, the 4d squared, 4d all squared is greater or equal to 0. K minus h squared is greater or equal to 0. So if we have that 4d all squared is greater or equal to 0, K minus h is greater or equal to 0. Now you can add these things up. K minus that squared, then 4d squared is greater or equal to 0. So if you add these two things up, you have greater or equal to 0, because the square of a real number is greater or equal to 0. If you square, even if you square a negative number, like -2 all squared, you get a +4. So if you square these things, you get numbers that are greater or equal to 0. Now, what is this k minus h all squared plus 4d? This is delta, so which means that delta is greater or equal to 0. And this means that the roots are real for all real values are real for all real values of k, values of hk. Roots are real for all real values of h, k, and d. Any question? Okay, this video is recorded, so you'll have a chance to sort of watch these in the... Okay, this one came in 2002 exam, IEB, Independent Examinations Board. Show that. Show that k squared x squared plus 2 is equal to kx minus x squared has non-real roots for all real values, of real values of k. This question was set in the IEB in November 2002 in the higher grade paper. Let's see the answer to this. Try it quickly. But we have a chance to discuss some past exam questions that came in the higher grade papers. Let's see what you can do. Show that. If you can't see the question, let me know, please. All right. You can't see the question. Alert me that you can't see the question. How far? Who is done? Who is done? Who is done?
Say it has no resolutions.
Yes, you done. Did you get it? Brando?
Yes, I did.
What did you get delta to be?
Uh,
Okay, k squared x squared plus 2 is equal to kx minus x squared. So at this point, you must write this one in standard form. Okay, so you have this, and then you move the x squared to the other side so that you have the x squared terms, and then you have minus kx, the kx moved across, and obviously it attains a negative, and we have plus 2 equals 0. K squared plus 1, x squared minus kx plus 2 equals 0. What is a here, guys? A is what? B is what? So B is minus K, and C is what? Which is K squared plus 1. B is minus K, and C is 2. So then what we're getting here is that we have delta is B squared minus 4AC. What is B? B is minus K. Minus 4A is K squared plus 1, and C is 2. And you square these, you have K squared minus 4 times 2. 4 times 2, or minus 4 times 2 is minus 8 to multiply, which is minus 8K squared minus 8. Like this. So what then do we get here? What then do we get here? Anyone? K squared minus 8 minus this. Complete the square here. So you have minus this. You have minus that, you divide by 2. You take the coefficient of, okay, there's no square here, please. Let me see. Okay, let's just add this quickly. K squared minus 8K squared is minus 7. K squared minus 8. So that which is exactly minus okay, so at this point you realize that k squared is greater or equal to 0. But if you multiply these by, you multiply it by 7, both left and right, inequality changes direction. So that minus, this is minus 0, or just 0. And then you have minus k squared, you subtract 8 from the left, and you subtract 8 from the right. So this becomes like 0 minus 8. Which means you have minus 7 k squared minus 8 is less or equal to minus 8. Okay, this is therefore delta, which equals this. Right, so obviously at this point, if delta is minus 8, or it is even less than that, it means therefore the conclusion is therefore delta. Delta is minus 7k squared minus 8, which is less or equal to minus 8. But minus 8 itself is less than 0. And this means that delta itself is less than what? Delta itself is negative. It's less than 0. Okay, if it happens, therefore, that delta itself is negative, less than 0, then we are able to conclude that this implies that the roots are non-real for all real values of k. That's the answer. The roots are non-real for all. Why are they non-real? Non-real means that delta is what? Is negative, right? Okay, obviously, let me give you a little homework on the roots that you're going to try at home. Prove that homework, a home activity. Prove that the roots of the equation plus AB minus P squared equals 0. Prove that the roots of the equation, this one, x squared minus into a plus b into x plus ab minus p squared equals 0 are real? For all real values of a, b, and p. Okay, so this is a home activity. Prove that the roots of the equation, this one, are real. Right, home activity. Prove that the roots of the equation x squared minus into a plus bx plus ab minus p squared equals 0 are real for all real values of a, b, and p. Prove that the roots of that equation are real. Okay, that is the homework you have on the nature of roots. I'm going to see you guys tomorrow again at 4 p.m. If you are busy at 4 p.m. because you're going to church, you can alert me, then you can have your class later on after 6. When you are done with the rest of the people, we can have your class alone. Okay, it's possible to do that. Okay.
Sir?
Yes, please.
I won't be able to attend tomorrow.
That's fine. If you can't attend tomorrow, then you can join us during the week. I'm gonna make allocation of time during the week. They're gonna be slots during the week. And I'm gonna put on the group the timetable, then you can choose the time that is gonna suit you during the week, and we can have our lesson during the week. If you are busy tomorrow. Okay. If you are busy on Saturday, these classes are not mandatory. So these online classes are flexible. So it depends on when you are free. You just alert me when you are free, and then your class can take place. If you are working, you are cooking, you are cleaning, I don't know, you are doing something at home, you alert me, and then we can have your class at a time when you are free. That's all. That is the beauty of online classes. We are very flexible. Doesn't mean that the class is only at 4 and it cannot take place at any other time. It does not mean that. Okay. Right, I'm gonna post the things on the group because I'm gonna add you guys on the group. Yeah, but thanks a lot on the WhatsApp group. I'm gonna add you guys there. Right, so thanks a lot, guys, for joining us today. I'm gonna see you guys at 4 p.m. That's okay. I understand that if you're busy tomorrow, it's okay. During the week, we're gonna have pop-up sessions during which we can have more math, more science. Thank you, guys. See the rest of you guys tomorrow. And yeah, I'm gonna make time allocations for meetings during the week or lessons during the week for those who are gonna be busy tomorrow. All right, thanks, guys. See you next time. I'm gonna send the video link in the next couple of minutes after uploading the video. Thank you and goodbye, everyone.
Yes, sir.
Goodbye, guys.